On May 6, 2025, the Japanese lunar lander Resilience, developed by the company ispace, successfully entered lunar orbit, marking a pivotal moment in the ongoing exploration of the Moon. This achievement is part of the HAKUTO-R M2 mission, which aims to attempt a historic lunar landing on June 5, 2025. The spacecraft's entry into lunar orbit was accomplished through a 9-minute burn of its main thruster, the longest burn conducted during its mission to date. Mission Overview. The HAKUTO-R M2 mission represents a vital step for ispace, which strives to establish a presence in the evolving landscape of lunar exploration. This mission follows the company's first lunar lander mission, which faced challenges leading to a crash during a landing attempt in April 2023. The successful entry into lunar orbit is a significant milestone, as it completes the 7th of 10 critical mission milestones defined by ispace. Key timeline of events. January 15, 2025, Resilience was launched at 6:11 Universal Time Coordinated aboard a SpaceX Falcon 9 rocket, sharing its launch with Firefly Aerospace's Blue Ghost lunar lander. February 14, 2025, the spacecraft performed a flyby of the Moon, reaching a distance of 1.1 million kilometers from Earth, allowing it to gather invaluable data on its systems and trajectory. April 24, 2025, all deep space maneuvers were completed, setting the stage for the lunar orbit insertion. May 6, 2025, Resilience successfully entered lunar orbit at 4:41 p.m. Eastern Time 2041 Universal Time Coordinated, transitioning smoothly into the next phase of its mission. Mission Objectives. Resilience's mission comprises several ambitious objectives. 1. Technological demonstration. The spacecraft aims to demonstrate new technologies that can be utilized for future lunar exploration and resource utilization. 2. Payloads. It carries various scientific and cultural payloads, including a mini rover named Tenacious, which is designed to collect lunar regolith and demonstrate mobility on the Moon's surface. The lander is also transporting a cultural artifact known as Moonhouse, created by Swedish artist Michael Genberg, along with scientific instruments from Japanese companies and a Taiwanese university. 3. Resource utilization. The mission seeks to explore the potential for utilizing lunar resources, thereby paving the way for sustainable lunar exploration. Technical details and challenges. The entry into lunar orbit was achieved through careful planning and execution. The main thruster burn required for orbital insertion lasted approximately 9 minutes, showcasing the operational experience ispace gained from its previous mission attempts. Following the successful maneuvers, Resilience is now positioned in a stable orbit above the lunar surface, with preparations underway for the landing phase. Future prospects. The landing attempt is scheduled for June 5, 2025, aimed at the Mare Frigoris region, a basaltic plain in the Moon's northern hemisphere. Should the landing be successful, it would mark Japan's second successful lunar landing, following the previous achievement with the SMART lander for investigating Moon Slim in January 2024. However, ispace has indicated that alternative landing sites are being considered in case adjustments are necessary. Reactions and implications. Industry analysts and space enthusiasts have closely followed Resilience's journey, with major publications like Space News and Space.com highlighting its significance. ispace CEO Takashi Hakamata expressed pride in the team's achievements, emphasizing the importance of the operational experience gained from prior missions. The successful entry into lunar orbit not only reflects ispace's advancements in lunar technology, but also positions Japan as a growing player in the realm of private lunar exploration. Conclusion. The entry of Resilience into lunar orbit marks a critical advancement for ispace and private lunar exploration. The upcoming landing attempt will serve as a test of technical capabilities and a step towards establishing a sustainable presence on the Moon. With ambitious objectives centered around technological demonstration and resource utilization, ispace is poised to contribute significantly to the future of lunar exploration and beyond. As the mission progresses, the global community eagerly awaits the outcomes of this historic endeavor. The entry of the Japanese lunar lander Resilience into lunar orbit on May 6, 2025, represents a notable achievement in private space exploration. Here are some counterintuitive insights gleaned from the information provided. 1. Low-energy trajectory versus direct path. While one might assume that reaching lunar orbit would require a direct and energy-intensive trajectory, Resilience took a low-energy fuel-conserving route. This is counterintuitive because many may believe that speed and directness are paramount in space travel, yet in this case a more gradual approach proved successful. 2. Cultural artifacts in space missions. The inclusion of cultural artifacts such as the Moonhouse by artist Michael Ginberg may seem extraneous to a scientific mission. However, these elements serve to humanize space exploration and promote cultural diversity, which is often overlooked in technical discussions about lunar missions. 3. Commercial agreements for lunar resources. The Resilience lander's micro-rover Tenacious is set to collect lunar regolith and transfer ownership to NASA under a $5,000 agreement. This arrangement may seem trivial in financial terms compared to the vast costs associated with space missions, but it underscores a nascent legal framework for lunar resource utilization, indicating a shift towards commercialization of space resources. 4. Learning from failure. The narrative emphasizes a space operational learning curve following a failed landing attempt during its first mission. Typically, failure in high-stakes missions leads companies to retreat from similar endeavors, but space used its previous setback as a learning opportunity. This reflects a counterintuitive approach in high technology where failure often leads to increased caution rather than bold progression. 5. Public versus technical perception. Space news focused on the technical maneuvers and implications for future projects, while Space.com emphasized the historical narrative of private exploration. This division highlights a counterintuitive disconnect. The public may be more interested in the cultural and inspirational aspects of space missions rather than the technical minutiae that experts prioritize. 6. Geographic and strategic implications. Resilience's planned landing in Mare Frigoris Sea of Cold in the Moon's northern hemisphere could be perceived as a simple choice of landing site. However, it reflects strategic considerations related to future lunar resource utilization and exploration which may not be immediately apparent to the general audience. 7. The role of private companies in space exploration. The fact that multiple private companies are now vying for lunar exploration is a paradigm shift. Traditionally, space exploration has been dominated by national agencies. The counterintuitive aspect here is that private entities are now leading the charge in what was once considered exclusively a governmental domain, suggesting a future where private interests play a significant role in space endeavors. These insights challenge conventional thinking about space missions and highlight the evolving landscape of lunar exploration where cultural, commercial, and technological factors intertwine. In the recent report concerning the lunar lander Resilience, which successfully entered lunar orbit on May 6, 2025, several aspects may be overlooked by the general public despite their significance. Below are key points that highlight these critical elements and their importance in the context of lunar exploration and technological advancements. 1. Technical maneuvers and learning curve. The orbital insertion burn, which lasted 9 minutes, represents the longest propulsion maneuver in the mission thus far. This technical achievement is not simply a milestone, it showcases a space learning curve and operational experience gained from previous missions, particularly after the failure of their first lunar lander in April 2023. The ability to adapt and apply lessons learned is crucial in space exploration where even minor errors can lead to mission failure. Significance. This aspect emphasizes the iterative nature of aerospace engineering and the importance of resilience in overcoming setbacks. The successful execution of complex maneuvers also reflects the increasing sophistication of private sector capabilities in space, which could lead to more frequent and reliable lunar missions in the future. 2. Cultural payloads and broader impact. The inclusion of the Moonhouse, an artistic installation by Swedish artist Michael Ginberg, and the UNESCO memory disk carrying linguistic and cultural diversity are notable components of the mission. These cultural artifacts serve not only as scientific instruments but also as symbols of humanity's aspirations and diversity in space exploration. Significance. This highlights a growing trend in space missions to incorporate cultural elements alongside scientific objectives. By doing so, missions can foster a sense of global unity and shared purpose in space exploration, potentially inspiring future generations about the importance of cultural heritage in the context of humanity's expansion into the cosmos. 3. Resource utilization and legal frameworks. The Resilience lander is set to perform a lunar regolith collection which will be transferred to NASA under a nominal agreement. This aspect of the mission underscores the evolving legal frameworks surrounding space resources and property rights, particularly as private entities begin to play more prominent roles in space exploration. Significance. This operation is not merely a technical task but a foray into the complexities of lunar resource utilization. As more missions aim to exploit lunar materials, understanding the legal implications of ownership and resource rights will be crucial. The successful collection and transfer of lunar materials could set precedents for future commercial endeavors on the Moon and beyond. 4. Environmental and sustainability considerations. The technology demonstrations planned for the Resilience mission include experiments focused on food production and water electrolysis equipment. These technologies are essential for long-term lunar habitation and sustainable exploration. Significance. The integration of sustainability-focused technologies into lunar missions is a crucial step towards establishing a human presence on the Moon. It emphasizes the need for future missions to consider not just exploration but also the establishment of sustainable ecosystems that can support human life, which is vital for long-term space exploration and eventual colonization. 5. International collaboration and commercial partnerships. The involvement of various international entities such as a Taiwanese university and multiple Japanese companies highlights the collaborative nature of modern space exploration. Ispace's partnership with NASA and other organizations underscores the blending of commercial and governmental efforts in achieving space exploration goals. Significance. This collaboration points to a future where international partnerships become the norm in space exploration, leveraging diverse expertise and resources to enhance mission success. Such collaborations can help mitigate costs and risks associated with space missions while promoting shared scientific goals. 6. Future missions and broader implications for space economy. Ispace's announcement of upcoming missions, including partnerships with NASA's Commercial Lunar Payload Services program, indicates a robust pipeline of lunar exploration endeavors. The company's strategy involves leveraging experience from the Resilience mission to further develop its capabilities and expand its presence in the space economy. Significance. The ongoing developments in a space mission trajectory reflect a burgeoning private space economy, where companies will increasingly participate in lunar exploration. This shift has broader implications for job creation, technological innovation, and international competitiveness in the aerospace sector. Conclusion. The Resilience lunar lander's entry into lunar orbit is more than just a technical milestone. It encapsulates a myriad of significant themes that are crucial for the future of lunar exploration and the broader space economy. From the resilience demonstrated in learning from past failures to the cultural and sustainability dimensions of this mission, each aspect contributes to a richer understanding of humanity's journey into space. As the landscape of space exploration evolves, recognizing and emphasizing these often overlooked elements will be essential for fostering a comprehensive and inclusive approach to our endeavors beyond Earth. 1. Significance of Resilience's lunar orbit achievement. The successful entry of the Resilience lunar lander into lunar orbit on May 6, 2025, marks a critical milestone in the HAKUTO-R M2 mission. This achievement not only showcases ispace's technical capabilities and operational experience gained from past missions but also positions Japan as a key player in the emerging landscape of private lunar exploration. The mission aims for a lunar landing on June 5, 2025, representing a significant step toward demonstrating sustainable exploration and potential resource utilization on the Moon. 2. Technological and cultural payloads. Resilience carries several payloads that emphasize both technological advancements and cultural contributions. Notably, the mission includes a mini rover Tenacious designed to explore the lunar surface and collect regolith, which highlights the emphasis on resource extraction. Additionally, the inclusion of the Moonhouse, a cultural artifact by artist Michael Genberg, reflects a growing recognition of the importance of cultural heritage in space exploration. This dual focus on technology and culture could influence future missions and the broader narrative of human presence on the Moon. 3. Operational learning in future missions. The operational maneuvers executed during the Resilience mission demonstrate a space learning curve following its previous mission setbacks. The company aims to leverage the insights gained from the Resilience project to enhance future lunar missions, including the upcoming Apex 1.0 lunar lander scheduled for 2026. This iterative approach underscores the importance of experience in the rapidly evolving field of private space exploration and the need for continuous learning to improve success rates. For broader context of private lunar exploration, Resilience's mission is set against the backdrop of a growing trend in private lunar exploration, with multiple companies vying for a role in lunar operations. The successful landing attempt would position ispace alongside other private entities like Firefly Aerospace and Intuitive Machines, contributing to a competitive yet collaborative environment in space exploration. This shift toward privatization reflects a broader trend in the space industry where commercial entities play significant roles in scientific discovery and resource utilization, potentially reshaping international partnerships and space policy in the coming years. These 4 points encapsulate the technological, cultural, operational, and contextual significance of the Resilience lunar lander's mission, providing a comprehensive framework for analyzing its impact on lunar exploration and the future of private space endeavors. 1. Apollo 11 Mission 1969. The Apollo 11 mission was a historic event that marked the first time humans set foot on the Moon. Launched on July 16, 1969, the mission was led by NASA astronauts Neil Armstrong, Edwin Buzz Aldrin, and Michael Collins. On July 20, 1969, the lunar module Eagle separated from the command module and descended to the lunar surface. Armstrong and Aldrin landed in the Sea of Tranquility, where Armstrong famously declared, "That's one small step for a man, one giant leap for mankind," as he stepped onto the lunar surface. The mission successfully returned to Earth on July 24, 1969, demonstrating human resilience and technological capability in space exploration. 2. Viking Program 1976. NASA's Viking program consisted of 2 spacecraft, Viking 1 and Viking 2, which were launched to Mars in 1975. The primary objective of the Viking missions was to search for signs of life on Mars and to perform high-resolution imaging of the Martian surface. Viking 1 successfully landed on Mars on July 20, 1976, with Viking 2 following suit on September 3, 1976. The missions provided extensive data about the Martian atmosphere, surface, and potential for life, marking a significant achievement in planetary exploration. The resilience displayed by the Viking program in overcoming technical challenges and achieving its scientific goals set the stage for future Mars exploration missions. 3. Mars Pathfinder 1997. The Mars Pathfinder mission, which launched on December 4, 1996, was a groundbreaking project that included a lander and a small rover named Sojourner. It successfully landed on Mars on July 4, 1997, showcasing the capability to explore the Martian surface with a robotic rover. Sojourner conducted extensive analyses of rocks and soil, sending back valuable data and images to Earth. The mission demonstrated the feasibility of low-cost robotic exploration of other planets and paved the way for future missions, such as the Mars exploration rovers. The resilience of the mission team in addressing challenges and the innovative use of technology allowed for a successful mission that significantly advanced our understanding of Mars. The successful entry of the Japanese lunar lander Resilience into lunar orbit on May 6, 2025 marks a significant advancement in lunar exploration and private space endeavors. As we look toward the future of lunar exploration, several key predictions and trends can be anticipated based on this milestone and the broader context of space exploration. 1. Increased private sector participation. The success of the Resilience mission, part of a space HAKUTO-R M2 mission, underscores the growing role of private companies in space exploration. With ispace and other private entities like SpaceX and Firefly Aerospace leading lunar missions, we can expect a surge in private investments and partnerships in the space sector. This trend will likely lead to more frequent lunar missions and a diversification of mission objectives, including scientific research, resource extraction, and even tourism. 2. Advancements in lunar technology. The technological advancements demonstrated by Resilience, particularly in its orbital maneuvers and payload capabilities, will pave the way for next-generation lunar landers and rovers. Future missions are likely to incorporate more sophisticated technologies such as autonomous navigation systems, enhanced communication systems, and better resource utilization strategies. This will be crucial as missions aim for longer durations on the lunar surface and the establishment of sustainable operations. 3. International collaboration. As lunar exploration becomes increasingly commercialized, international collaboration will play a vital role. Countries and private entities may form partnerships to share technology, reduce costs, and pool resources for more ambitious missions. We may see collaborative efforts for joint lunar bases, shared scientific research, and global initiatives for sustainable lunar development, particularly in resource management and environmental protection. 4. Resource utilization on the Moon. The focus on resource utilization exemplified by Resilience's mission objectives suggests a shift towards exploring the Moon's rich resources such as water, ice, and rare materials. Future missions will likely prioritize in-situ resource utilization (ISRU) technologies that allow astronauts and robotic systems to use lunar materials for life support, fuel production, and construction. This will be essential for establishing a long-term human presence on the Moon. 5. Cultural and scientific contributions. The incorporation of cultural artifacts such as the Moonhouse created by artist Michael Genberg signals a growing recognition of the importance of cultural contributions alongside scientific exploration. Future missions may increasingly blend art, culture, and science, fostering a deeper connection between humanity and space exploration. This could manifest in various ways, from artistic installations on the lunar surface to educational outreach programs designed to inspire future generations. 6. Regulatory and ethical frameworks. As lunar exploration expands, the need for comprehensive regulatory frameworks will become more pressing. The international community will need to address legal and ethical considerations surrounding lunar property rights, resource utilization, and the environmental impact of lunar activities. Future developments may include treaties or agreements that govern the conduct of nations and private entities in space, ensuring sustainable practices are followed. 7. Preparations for human exploration. With Resilience's successful entry into lunar orbit, the groundwork is being laid for future crewed missions to the Moon. The advancements in technology and operational experience gained from missions like HAKUTO-R M2 will inform NASA's Artemis program and other planned crewed lunar missions. We can expect to see human landings on the Moon within the next few years, with an emphasis on establishing a permanent human presence. 8. Lunar bases and infrastructure development. The establishment of a lunar base is likely to be a key objective for many future missions. As private companies and space agencies plan more ambitious projects, we may see the development of infrastructure that supports long-term human habitation, scientific research, and commercial activities. This could include habitats, research facilities, and launch systems that facilitate easier access to and from the lunar surface. 9. Growing interest in lunar tourism. As technology evolves and lunar missions become more routine, the prospect of lunar tourism may emerge as a viable commercial endeavor. Private companies could offer trips to the moon for wealthy tourists, leading to a new frontier in space travel. This could stimulate further investments in space technology and infrastructure, making space more accessible to the general public. 10. Educational and inspirational impact. The achievements of missions like Resilience will inspire future generations to pursue careers in science, technology, engineering, and mathematics STEM. Educational programs that highlight these missions will likely grow in prominence, fostering a culture of innovation and exploration. This could lead to increased interest in space sciences and the development of a skilled workforce ready to tackle the challenges of future space exploration. In conclusion, the successful entry of the Resilience lunar lander into lunar orbit is not just a milestone for space but a significant step forward for humanity's exploration of the moon. The future of lunar exploration is poised for rapid development, driven by technological advancements, increased international collaboration, and a focus on sustainable practices. As we approach the next decade, we can expect a vibrant and dynamic landscape in the realm of lunar exploration, with new opportunities and challenges on the horizon.